The sound of a legend. Porsche 911, the world's most successful sports car. Its rear-mounted boxer engine and classic styling are unmistakable. It combines sportiness and everyday functionality like no other vehicle. A street-legal race car. To me, it's an expression of style. Here's where the famous 911 is made. In Stuttgart Zuffenhausen, Germany has been producing one of the icons of the automotive industry since 1963. It's the best-known sports car in the world. At the inner sanctum of the Porsche faithful, the Weissach Development Center, engineers work to make each new generation of the sports coupe even better than its predecessor, while always remaining nothing less than a genuine 911. I believe there's no other product in the automotive world with a comparable life story. A unique design from day one, and an unequaled racing history over the course of decades. The 911 has earned the label legend. Many want a part of racing history for their very own, preferably in like-new condition. We can restore almost everything. And now, the sports car's 8th generation is also on its way to becoming a legend on 4 wheels. Once a 911, always a 911. Porsche Platz in Zuffenhausen, Germany. This is where they build the legendary 911. The sports car builder's main plant is a place with a long tradition. Since the first 911 was created here in 1963, a small Swabian speedster has achieved mythical heights, and the name Porsche has become world-renowned. The result of decades of research and development. Now, the 3,000 employees in series production fabricate around 250 cars per day. The Zuffenhausen plant is Porsche's home sweet home, and the 911 is clearly the icon of the Porsche brand. Since every 911 ever built, well over 1 million now, came from this factory in Zuffenhausen, it's easy to understand the importance the plant places on the 911. The list price for the top model, the 911 Turbo S, is just over 200,000 euros. For that sum, the proud owner comes away with a 1.6-ton sports car with a 650 horsepower engine. To accelerate from 0 to 100 kilometers per hour, the 911 Turbo S takes just under 2.7 seconds. Its 6-cylinder boxer engine, with 2 turbochargers, can push the speedometer's needle past the 300 km/h mark. At the heart of the 188-acre Porsche plant lies the birthplace of every 911. The sports car's exterior is produced in the bodyworks. 350 employees and 286 robots weld, glue, and rivet the sports car into its striking shape. This body will eventually become a Turbo S, the most powerful version of the 911. With its distinctive air intakes right in front of the rear wheels, they channel fresh air to the 2 turbochargers. So, it's already easy to tell from the openings in the body shell that this is a turbo. As with every 911, the important thing here is to make the car's exterior as light as possible, because every extra kilogram ultimately sacrifices more efficiency and speed. The 911's body is lightweight construction. Of course, a sports car with a very, very heavy body will never be a sports car. That's why extremely lightweight construction is also what, in our view, distinguishes the 911. We have highly specialized material composites. We have an aluminum shell. We have high-strength steels right where it matters. Intelligent lightweight construction. That's a top priority. The complex transport system of the plant is also intelligent. The bodies move from station to station on their own mezzanine just below the ceiling. That saves space, and the Swabians desperately need it. A car plant right in the middle of a city, like the one here in Stuttgart Zuffenhausen, actually borders on sheer impossibility. The Porsche plant rises several stories, and each floor is packed to the gills with workstations. There are 130 in the bodyworks alone. Robots handle most of the high-precision punching, welding, and gluing. The machines are more accurate than humans, and they work longer hours. A robot doesn't even know what it means to get tired. On a transport sled, the bodies enter the home stretch. From here on in, the final 50 meters, human hands can also intervene. Here, 30 employees install the last parts, such as the trunk lid, which, as everyone knows, is in the front of the 911. Once the hinges have been bolted on, the employees verify the gaps. When those gaps exceed specifications, wind noise can get loud fast at top speed. After 4 hours, each of the 236 kilogram bodies is whisked away in an elevator and automatically transferred to one of the paint shops. The path they take is another unique feature of the plant. Conveyed through overhead skyways high above the grounds of the plant, the cars move from one production hall to another. All Porsche 911s are painted in the main plant in Zuffenhausen. The priming of the bodies begins in a cathodic electro-deposition bath. Electric current flows through the entire basin. The coating it contains is positively charged, while the vehicle itself is negatively grounded. There's a mutual attraction between the car and the primer. This enables the 20-micron, 0.8 mm thick primer to reach even the smallest cavities, providing first-class corrosion protection throughout. Then the machines get busy again. Robots spray on 3 more coatings, one to protect against stone impacts, then the actual color coating, and finally, the clear coat. The entire process takes 9 hours. Upon completion, the car weighs about 19 kilograms more. The coated bodies continue their journey, moving along a 250-meter overhead route to the other end of the plant site. The sports car legend's basic outline is already apparent. That's the way it should be, because one rule has never changed: a 911 must look like a 911. In the early 1960s, the first generation established its paradigmatic look: prominent headlights flanking a flat hood and the continuous sweep of the roofline back to the rear end. This design has long been considered a classic. One of the specifications right from the start was that everyone should be able to identify the car as a Porsche by its silhouette. And that meant a fastback. But what later became the legendary 911 had a different name at first. The first 100 cars were still sold under the originally intended number -901. And that's also how it was unveiled at the 1963 Auto Show in Frankfurt am Main, Germany. The first new development from Porsche in 15 years. But then, Peugeot raised an objection to the name, because the French automaker reserved the right to all model designations with a 0 in the middle. Porsche simply turned the 901 into the 911 and set a new benchmark. The first models had a 2-liter, 6-cylinder, rear-mounted boxer engine. 130 horsepower accelerated it up to 210 kilometers per hour. Extreme performance in those days. From day one, the new Porsche was a genuine sports car, and it also came at a price -21,900 Deutsche Marks, about 3 times the price of its predecessor, the 356. That pales in comparison to the value of first and second generation 911s today. Now, a fully restored one-of-a-kind can cost nearly €1 million. The specialists at early 911s in Wuppertal, Germany, transform rust buckets into gleaming collector's items. The men and women here specialize in the model series 356 through 993, which still had an air-cooled engine. For complete restorations, the waiting list is long. Some of these projects take years for the employees to complete. Their motto: almost nothing is beyond repair. We can restore almost everything. There are wear limits in the engine, transmission, and suspensions, where we purchase original parts from Porsche. So about 30% of every car is completely new. That means, for example, body parts, of course, in order to restore services. You can restore practically everything in the interiors. Some 450 old Porsches await their second or third reincarnation. At the moment, there's an F model, a first-generation 911, on the straightening bench, a 2.4-liter Targa from 1972. This car has been restored again and again, but the damaged front and back have never been properly repaired. As a result, the car is crooked and skewed. That's typical. The hardest part of most restorations does not involve the engine or the suspension, but rather the manual work on the body. Here we have the frame bench, especially designed for the F model. Then we've got a frame gauge up front that tells us how to position the windshield. In the back, a frame gauge positions the rear window. When everything fits and the frame gauges for the doors align, then I can be sure that the car will be straight when it's all done. The body makers unceremoniously cut a section of sheet metal from the 50-year-old car. The part is simply beyond repair. Now, this is also the part that connects the whole driver's side rear axle to the rest of the car. This part is almost certain to impair road handling. When you look at it, there's just no way to attach a rear axle to it properly, much less adjust it properly afterward. If you take a look at it now, it's been messed around with so much, even inside, that we had no choice but to take the whole section out and fabricate a new one in its place. The employees put 500 to 1,500 man-hours into the classic car's body alone until it looks like this. But a historic 911 is a dream car after all. That has its price, and can also take a lot of time. In Zuffenhausen, individual dream cars are built in series production. All of the company's two-door sports cars come from this assembly line. Not only all 911 models, but also all 718s like the Boxster and the Cayman. A fully painted body rolls off the assembly line at the first of 117 stations. Assemblers mount protective shells to prevent scratches and damage, then remove the doors. This gives mechanics easier access to the interior. An elevator takes the driver's side door to station 108, one floor below, where it will be reassembled on the car a few hours from now. These employees slide a heavy sack into the car. It contains the car's nervous system, the wire harness. Supplied as a prefabricated assembly, it now only needs to be routed. This operation takes 4 men, because the work must be completed in 175 seconds. That's the cycle time. Then comes the next car. The assembly line advances at 2 meters per minute. No two cars are alike. A 911 can be followed by a Cayman. The employees here are perfectly trained to assemble all models. The challenge, of course, is the high qualification level of our employees, and this enables us to produce all cars on one series production line, from the basic 911 to the Cup race car. The advantage is that we only need one body works, one paint shop, and one car assembly line for our entire two-door sports car product range. At the next station, the employees install the instrument panel. Their cockpit pre-installation colleagues have already assembled it at a small assembly line right next to the main line. Using an assembly arm, a mechanic slides the finished instrument panel into the car. To prevent damage, the component is covered with a blue protective mat. The tachometer, not the speedometer, is located in the middle. That's where it belongs in a 911. Because racing drivers are concerned with RPM, not kilometers per hour. A few meters later, every convertible gets a life-saving component, the roll bar. Should the car ever roll over, 2 bars will extend within fractions of a second to protect the heads of the occupants. Each variant of the 911, whether coupe, cabriolet, targa, or speedster, is equipped with special extras. That's complicated, but the wide range of models helps boost sales. These advanced developments, known as derivatives, are a Porsche tradition. The first 911 convertible, the Targa, comes with a stylish, unique selling point: the distinctive roll bar mounted behind the doors. What later became a worldwide success was born out of necessity. In order to be able to sell the convertible on the important US market, it had to comply with the safety regulations enforced there at the time. A pure convertible was prohibited, so Porsche quickly invented the Targa roll bar. A classic convertible without a roll bar was not launched until 1983. Over the years, the model range has continuously grown, and the range of colors along with it. Out on the road, the 911 also stands out for its many special coatings. Few of its contemporaries are as colorful as this sports car. And it's also getting stronger, wider, and flashier. More and more of a true racing car. The ducktail rear spoiler is the hallmark of this development. Then, in 1975, a new top model appears, the Turbo. For about 65,000 Deutsche Marks, the customer gets a 260 horsepower car that can reach top speeds of more than 250 kilometers per hour. The Turbo 2 soon becomes a classic. The Porsche Museum in Zuffenhausen is a treasure trove of legends. The cars that made it into this exhibit were pioneers of technical development. More than 80 display pieces on 3 floors tell the story of the once small company's great successes. Here too, the star, time and again, is the 911 in a vast range of variants. In the 1990s, Bent Cano helped write part of that success story as the model series director. Over the years, we were more and more successful at achieving a fusion of sport and comfort. So, you could drive around the Nürburgring in each new 911 faster than its predecessor. And at the same time, it was also more comfortable. That was the secret to how we actually got the production volume up to a level where we could earn money and keep Porsche in business. Porsche also brought many special models to the market. One of them was the Speedster with a racing enclosure instead of a roof, which was very costly to produce. Inside the company, this top section was affectionately known as the toilet lid. The idea behind the toilet lid was to give a bit of the sensation of driving a Formula One car, something like sitting in an open cockpit. It was extremely difficult. You had to wear a helmet, and we were glad that nobody wanted one. A few yards away, there's another one of these rare 911s that hardly anyone wanted, a hardtop convertible with its own surfboard. We spent a whole lot of money back then to develop this, and then sold practically none of them. Customers wanted to drive a convertible with the top down. They probably just dropped the surfboard off someplace and kept on driving. There's a marketing group that claims, "We need this, but for us, we have the feeling we don't." But what does the customer need? That's always difficult to determine. And then there's one more unique specimen, which actually could have given rise to a promising niche product. Once, I had an idea that there was a market for armored 911s, with bulletproof glass, special door sections, and reinforced panels behind the body. It still wasn't too heavy, so it could still be driven as a proper sports car. However, the second armored 911 was never produced. Today, bulletproof panes still have yet to reach the assembly line in Zuffenhausen. This is laminated glass. First, a robot applies a thin layer of special adhesive. Then, the employees carefully install the pane. A vacuum lifter helps them position the glass down to the millimeter. At speeds approaching 320 kilometers per hour, any tiny imperfection in the windshield can have fatal consequences. The first part of the assembly line has completed its work. The instrument panel, onboard electronics, and most of the car's shell are now complete. An elevator lowers the future 911 to the floor below. The car traverses the next stations in a rotary conveyor, suspended from the ceiling. The frame always holds the body precisely at working height and turns it into position. This gives employees optimal access to the car at all times. Along the edge of this section of the assembly line, the fuel tanks are already lined up and ready for installation. They're made of non-flammable plastic and have a 67-liter capacity. According to the manufacturer, that gives the sports car a range of more than 750 kilometers on the highway. An employee installs the fuel tank from underneath. In the 911, the tank is located in the front, just behind the luggage compartment. The next step is a momentous occasion. The marriage ceremony begins. The term engine marriage refers to the process of connecting the drivetrain to the body. Two assembly lines merge at this intersection. On the left, from pre-assembly, The driveless transport system supplies the pre-assembled drive module with suspension, engine, and exhaust system. On the right, the upper section arrives from the assembly line, suspended from the ceiling. When the two sub-assemblies are lined up, one on top of the other, the rotary conveyor slowly lowers the body onto the running gear. This is the moment of the marriage. 4 employees, acting as groomsmen, join the body and drive a train together with minute precision. To ensure that this marriage really endures, the team secures the module with 96 screws. Technicians previously assembled the drivetrain on an assembly line. 4 independent wheel suspensions for the all-wheel drive, the exhaust system, the transmission, and of course, the centerpiece, the Boxer engine. That assembly line is located in a production hall of its own. Here, 350 employees do nothing other than build engines. The power units traverse 100 workstations before completion. Along the way, they undergo a series of functional tests. I/O, which means OK and a green light, indicates that assembly can continue. And I/O, which means not OK, indicates that manual rework is required. 40 different models are produced here, but they all have one thing in common. They're Boxer engines. Every engine arrives in individual parts: the 2 halves of the crankcase, crankshaft, pistons, and 6 connecting rods. At this station, an employee prepares for the assembly of the Boxer engine by attaching each piston to a connecting rod. He then inserts the finished components into the 6 cylinders, where combustion will occur later on. The conveyor belt rolls on. Every 2 minutes and 47 seconds, the next employee installs the crankshaft. Later, it will transfer the motion of the pistons to the transmission. In a safety cage, a robot joins the 2 halves of the Boxer motor precisely at a 180-degree angle. 2 rows of 3 cylinders, each are arranged in a flat plane across from one another. That's what makes the Boxer engine unique. In a common V engine, 2 rows of cylinders are arranged in a V formation, hence the name. The piston pairs move in a slightly offset sequence relative to one another, so one lags behind the other. In the Boxer engine, however, the piston rows are arranged at 180-degree angles to one another, and each pair operates synchronously. When one piston moves toward the crankshaft, the other mirrors the exact same motion, like 2 boxers dancing toward each other and then separating again. This principle results in smoother operation. The Boxer engine profile is extremely flat, so it has a very low center of gravity, which is important for the car and its driving dynamics. The engine has to fit in the rear of the car. That would be difficult with a V8 engine. Most strikingly, the orientation of the Boxer engine is not vertical, but lies flat. This approach has a long tradition at Porsche, because the 911 has been powered by a horizontal 6-cylinder Boxer engine since its inception. Back to the restoration pros in Wuppertal. The mechanics here appreciate the old air-cooled Boxer engines. These engines are excellent candidates for restoration. Professionals also refer to this as rebuilding an engine. The Boxers are overhauled in a separate building. Nearly all spare parts are still available today. Engine work is routine for these mechanics. In terms of time, the engine rebuild is actually relatively manageable. From disassembly to completion, it takes about 6 weeks. Generally, the design of the air-cooled Boxers is much simpler than that of modern engines, which have water cooling and complex electronics. The question of air-cooled versus water-cooled engines has always split Porsche fans into 2 camps. For the Wuppertal team, the original air-cooled 911 is the only way to go. On the streets today, I think the old 911 is the most beautiful car, with its extreme understatement. When you buy an old car like this, everyone is actually indulgent toward you. Drive around in a modern Porsche, and there's usually a huge jealousy factor. The classic is more likely to get a thumbs up. In all, more than 400,000 air-cooled 911s were built, but only the rarest of them ever make it into the workshop. I look for special cars all over the world. Special cars mean history, special colors, or just special limited edition models. The first owner of this 4th generation turbo was a regular Porsche customer. She always ordered her 911s in blood orange. Each one is a unique specimen. After restoration, this car will be worth about 350,000 euros. The old turbos have a special characteristic, the infamous turbo lag. When the driver hits the gas, not much happens at first until the turbocharger builds up pressure. But then, the full power suddenly kicks in, and the car takes off. That can be dangerous, especially in curves. Too dangerous for some car collectors. We modify the turbo lag for the modern driver by adjusting the engine characteristics a little. We install a different camshaft, and the turbocharger is slightly modified. This makes it much smoother for many people who simply aren't accustomed to driving one of these old cars. And then, it's perfectly suitable for everyday use. Porsche engineers were aware of the turbo lag problem and eventually solved it over the course of development. But today, the turbocharger principle remains the same, even in the models currently coming out of Zuffenhausen. The exhaust gas flowing from the engine drives the turbine of the turbocharger. The latter, in turn, increases the fresh air supply to the engine, which delivers more horsepower. Mounted to the engine block of the newest 911 are not one, but 2 turbochargers. With them, the car reaches an impressive 650 horsepower. Here too, the mechanics have just 2 minutes and 50 seconds to complete the installation. They have to keep pace, as the entire engine must be fully assembled within 5 hours. My colleagues here in assembly handle 900 parts, including individual components and hardware such as screws, as well as separate sub-assemblies. That's 900 parts to produce one turbo engine. Finally, each engine goes on the test stand. An employee rolls the engine into a high-security chamber. This is where the heat test is performed. He connects the utilities to the engine, electrical power supply, fuel line, and extraction hoses that collect the exhaust gases. The measurement will show if everything works and whether the engine delivers full power. The door closes, and the heat test begins. The fully automated system slowly brings the Boxer engine up to speed. At 2,500 RPM, the engine starts to warm up. The computer then relentlessly pushes power output to the maximum. For 90 seconds, the system applies full throttle. The sensors continuously measure dozens of parameters, such as torque, oil temperature, coolant temperature, fuel pressure, and charge air pressure. This engine has passed the test. The department releases 260 engines per day, all in sync, so they can be installed at the right time. There's no warehouse for the engines. Our logistics system has to be very sophisticated because it's tremendously important to have the right part, with the right quality, in the right place, at the right time. We can't just store the parts in a warehouse. Autonomous trolleys move the engines toward the series production area. The driverless transport system, known as FTS, delivers them to a kind of shunting yard. Behind these automatic doors, there is a gigantic high bay storage rack, off limits to employees. A fully automated crane handles all the work. It parks the Boxer engines on the rack for a short time. A software program notifies the system when the assembly line needs a specific engine. The crane immediately retrieves the appropriate engine. It's all done within a matter of minutes. Meanwhile, the FTS is already delivering the next Boxer engine. Traffic continuously shuffles back and forth. Elsewhere, however, absolute silence reigns. No sound from outside may disturb the acoustics laboratory. This is where the sound of the 911 is measured, and this is how it looks. My 911, to my way of thinking, must develop a voluminous, powerful sound down below, and this typical howl at the top. Here we visualize the sound of the acceleration sequence that we just executed. You'll see this is the RPM axis. The car runs from 1,500 RPM. In our case now, up to 6,000 RPM. Then, here on this axis, we see how high the frequency is, or how high the tone is. The color indicates how loud it is. Blue is soft, while red and yellow show where the engine roars. So now, I can use this diagram to interpret the car's acoustic fingerprint. The fingerprint is generated using microphones, which are arranged at a precisely specified distance around the car. The insulation of the sound chamber is more than a full meter thick, ensuring absolute silence. The room itself is mounted on dampers to prevent vibrations from infiltrating. To measure the hearing impression inside the car precisely, a passenger dummy is also used. Like the driver, it also wears microphones on its head. My passenger, in this case, is a dummy head with a built-in microphone. It's made in the shape of a human torso, and you can see here that the ears have also been made to resemble a human ear. This is simply to record the passenger's hearing impression with the greatest possible aural accuracy. The engineer generates a complete sound profile. This means starting out slowly at 1,500 RPM, then accelerating at full throttle up to 6,000 RPM in fourth gear, maintaining speed, and finally letting the car coast to a stop at idle. In just under 2 minutes, the test is over. The basic principle also applies to the 911. The engine makes the sound, but the exhaust system also plays a decisive role, especially the position of the exhaust pipes. The tailpipe position is crucial. This tailpipe position, of course, also has a significant impact on the sound. People are unaware that moving the tailpipes closer together offers different design possibilities than when they are separated, as they are here. This sport exhaust system is characterized by its robust, coarse sound pattern, which then sort of gets out of hand again at higher RPMs and breaks into that distinctive sawmill sound. And after all, getting a little out of hand is what the 911 is all about. The sound laboratory is part of the Porsche development grounds in Weissach, Germany, 25 kilometers from the outskirts of Stuttgart. This is also where the company's own test track is located. Every new sports car generation is first subjected to extensive testing. According to company philosophy, it must be ready not only for the road, but also for the racing circuit. Over the course of its lifetime, the 911 has already put that philosophy to the test many times. In 1965, the racing debut at the Monte Carlo Rally marked the beginning. That's also where it chalked up its first major successes. The 911 earned 3 consecutive victories from 1968 to 1970, the first chapter of a success story that continues to this day. Time and again, the 911's reliability pays off in endurance races. In 1973, a 911 won the 24 Hours of Daytona with a 128-kilometer lead over the competition. At the 24 Hours of Le Mans, there's been an ongoing series of class victories. But the normal 911 doesn't quite make it to the top. That requires further development. One such development is the Porsche 935, a highly modified 911 Turbo. In 1979, the private team Creamer piloted it to a sensational victory in the French Classic. Nearly 20 years later, a 911 succeeded there again. The GT1, originally developed from the street-legal version, was subsequently refined with so many performance enhancements over the years that it had almost nothing in common with the 911 anymore, apart from the name. In front of the rear axle sat a mid-mounted engine, and it was even water-cooled. Is it still a 911? Asked many Porsche fans. Nevertheless, it won the 24 Hours of Le Mans in 1998 with a double victory. Again and again, the sports car proves that it thrives not only on the racetrack, but also off-road. With the newly developed 953, Porsche won the Paris-Dakar Rally in 1984. Rather than being lowered to the ground, the car was raised up higher, to just over 27 centimeters of suspension travel. A 911 with all-wheel drive, improved shock absorbers, and a reinforced rear axle. It was Porsche's first ever start in the rally, and the first time the event was won by a car that wasn't an off-road vehicle. And then Stuttgart's specialists went on to build a genuine supersports car, disguised as a rally car. In the mid-1980s, the 959 was a revolution on four wheels, and it also won the Paris-Dakar Rally. With the 959, we wanted to showcase all the technical possibilities: all-wheel drive, high-speed, twin turbochargers, and so on. Everything that was technically possible at the time. The technicians called the car the Rolling Research Lab. Many of its findings were eventually applied to the 911 series production. However, all that technology initially added a significant amount of weight, close to 1.5 tons. Nevertheless, the 959 reached a top speed of 317 kilometers per hour. Don't forget, this was the first time that a car reached speeds well over 300 kilometers per hour while carrying the weight of a small truck. It was no race car in terms of weight, even though it had the performance of one. It couldn't be scaled up for serious production. There was a tremendous amount of development work that we hadn't anticipated, so we went into series production much later than originally planned. That's why the car ultimately became so expensive. In the mid-1980s, the 959 was listed for 420,000 Deutsche Marks. Porsche built just 292 of them. Back then, it was the super sports car. Many wealthy buyers said, "I need one, no matter how well or badly it drives." And it was actually a great investment. If you look at how fast prices skyrocketed over time, it was just unbelievable. Today, a model like this can cost about €1,000,000. The restoration pros in Wuppertal happen to have one in their shop at the moment. With many kilometers on the odometer and a famous original owner, the car still has its original factory paint job. Surprisingly, this particular 959 has never been restored. It has only been repaired over and over again. The original owner, tennis star Boris Becker's mother. Becker bought it and registered it under his mother's name. The last owner drove it extensively. Normally, cars offered at auction have between 10,000 and 30,000 kilometers on the clock. This one has 124,000 kilometers and is in a rather used condition. Inside, you can see that it has never been restored. A lot of money has been invested in technology, but in my opinion, it's really more of a restoration project. However, restoring it is not an easy task. The 959 requires many non-standard parts that are not readily available. There's also much more electronic complexity in a 959 than in an older 911. To restore this car properly, it would have to go back to the factory, and that would cost a small fortune. If Porsche were to restore it, it would cost roughly 300,000 to 400,000 euros. And then you have to get it on the road. Standing still is what really kills a car. The differences between the 959 and the 911 of its era are clear. The 959 had variable all-wheel drive, extensive electronics, and performance specs that still hold up well against today's Carrera S. This car was ahead of its time. Many Porsche fans asked, "Is this still a 911? Sure, it's a 911. Absolutely. One thing is clear, the 959's advanced technology eventually made its way to serial production. So the test lab on four wheels still lives on in the Porsche 911 today. At Zuffenhausen, employees now install more electronics in a 911 than ever before. On the last section of the assembly line, this turbos is being fitted with critical aerodynamic components. At the rear, an employee installs key elements of the movable rear wing. It electromechanically adjusts itself to driving conditions. At 90 kilometers per hour, the wing deploys automatically. At higher speeds, the angle of attack increases to generate more downforce. The deployable wing is a characteristic feature. installed exactly where the famous ducktail rear spoiler used to be. We use the word spoiler if the air flows only across the top, like a typical ducktail or rear lip spoiler. We say wing if the air flows both across the top and underneath. The wing is much more efficient and generates a significant amount of downforce. That's why aerodynamic engineers always try to make it as wide and low as possible, configure it as a wing, and deploy it as far out as possible to prevent disturbing the airflow underneath, which is critical for efficiency. At the front, there are variable aerodynamic elements as well. A front spoiler made of plastic is installed under the bumper. By filling it with compressed air, the component extends while the car is moving. The airstream is also affected by the flaps in the front air intakes. The onboard computer adjusts their angle of attack according to speed and cooling requirements. Together, all the aerodynamic components installed in Zuffenhausen increase the car's downforce by up to 170 kilograms. Aerodynamics is an art. You're constantly torn between efficiency, meaning the lowest possible air resistance, and downforce. You look at the wheels, the spokes, what effect do they have? You make the underbody smooth, countersink the screw holes, and design gaps and transitions properly, all while ensuring that these details can be replicated in production every single day. But before the sports car leaves the factory, it must first be developed. Since the 1970s, this has taken place at the Porsche Development Center in Weissach. To date, engineers here have registered more than 7,000 patents. The facility is now considered one of Germany's most carefully guarded industrial sites. 6,500 people work here, more than 5,000 of them in development. Developing a new Porsche 911 costs millions of euros. In the 9,000 square meter design center, employees are already creating the sports car of tomorrow. By the time a world premiere is unveiled to the public, the car is already practically a relic to the designers. Their work was completed a long time ago. The exact duration of the development process is a closely guarded trade secret. Every new 911 faces the same challenge. It must not be too new. The key is to make the latest 911 instantly recognizable as the next generation, while preserving the unmistakable identity of the 911. So we have to strike a balance. How progressive do we go with new design elements? Upstairs, the designers first draft a basic outline on the computer. On the ground floor, employees then create physical models in various sizes, culminating in a full-scale clay model. The team adds plastic rims and lamps to the mock-up. Then, a special film is glued to the entire model. This simulates the paintwork and allows developers to study how light reflects off the surface. To the naked eye, the model is nearly indistinguishable from a real car. For the designers, working on the 911 remains something special. This sports car defines the look for the entire Porsche model range. We have a clearly defined design DNA, and all the essential elements responsible for Porsche's brand identity ultimately come from the 911. For example, the front fenders sit higher than the hood. That's what we call topography. When I look at the back of the car, I see the heavily accentuated shoulders. There are several such essential elements, and they can all be traced back to the 911. The 911 has retained its basic shape for decades. Its flat front, prominent headlights, and sweeping roofline extending to the rear. The internal model numbers may be confusing to outsiders. The 997 was followed by the 991. Porsche enthusiasts can instantly identify the generation from these numbers. Over time, the 911 has grown longer and above all wider. However, the designers insist it should never appear too aggressive. Slight understatement is the goal. In my view, the 911's proportions already say, I'm a sports car, without being overly aggressive. I could if I wanted to, but I don't have to all the time. While specialists continue refining the design, the first prototypes undergo grueling test programs. The engine runs between 200 and 800 hours on the test stand. an endurance test that pushes the limits of reliability. The Porsche 911, more than just a car, it's a legacy of speed, precision, and innovation. From its iconic silhouette to its cutting-edge engineering, the 911 continues to define what a true sports car should be. If you enjoyed this deep dive into the world of Porsche, don't forget to hit that like button and subscribe to our channel for more fascinating automotive content. Turn on the notification bell so you never miss an update on the latest supercars, engineering marvels, and automotive legends. What's your favorite generation of the 911? Let us know in the comments below. See you in the next video.